Starting to record. Oh, there we go. So welcome once again. Thank you so much. And like I said, the intention here was to have a face-to-face lesson today, but we were sort of advised that there was some protest action. Hello. Oh, okay. So then, because we have our major test 2 on the 23rd of May, we only have a few more lectures before we complete the syllabus. So missing another double would be a bit difficult for us to, I don't want to rush through the syllabus and then at the end we have people getting confused. So that's the reason why I've decided for the Teams lecture. Then with regards to major test 1 and marks, these marks are being captured at the moment. We've got mathematics 2, like I said previously, being captured. We have a new system. We have a new secretary. In fact, we have a temporary secretary, and she's having to capture 3,000 marks, and that's not easy for her to do. And so she's actually doing it one script at a time. That is a lot of work, but hopefully we'll get that sorted out. So that's major test 1. Hopefully you enjoyed minor test 3. If you were in class, if you watched that video, I think there were sufficient problems to have enabled you to do very well in that test. And thanks to your questions as well, which I included in our revision lectures, I think that was very useful. All right. And now the focus should be the very last, and it is major test 2. That major test 2 is going to be written on the 23rd of May. It's a sit-down test, 90 minutes, and it will include everything from minor test 3 all the way up to where we finish off, and that is integration. So there's a lot of work coming our way, but I think it's going to be interesting, and I'm not going to say easy, but enjoyable. So let's get started. Let's try to finish up the differentiation part, and then we'll get on to antiderivatives next week. So before I start, are there any questions? Anything bothering anyone? Everybody's happy? Oh yes, before I forget, there's one more thing. I think these LEQs, MEQs, SEQs, these are these questionnaires that you should be sort of filling in. And that is basically to give us more insight in how the course is delivered, whether you're happy with the lecturing, whether you're happy with the support. I think that's extremely important. So there will be a link on Moodle. Please visit. It'll only take you about 5 minutes to fill in the LEQ, MEQ, I think it is. And so we will get some feedback. All right. So I think that's important. So let's get started. I just want to take away that video, which is a very scary video of me, and then share my screen. Here we go. So share screen. That is my screen. But we're going to start off with this lecture, and that I like to call it techniques of differentiation. And it will form a very large portion of major test 2, right? Including limits, which we also did in the minor test 3. So we already know the notion of a derivative. If I have asked you to work out the derivative of f of x equal to x squared plus 1 from first principles, we know that's a question that can be asked in major test 2. I think everyone would be able to do that. But what we want to do now is to apply the rules for differentiation. When we were in school, we only learned one rule. That was the power rule. And that was a pretty straightforward rule. But in order to appreciate the other derivatives or the rules, we need to come up with what we call some very common derivatives that we would see in applications. Okay. So for example, the first one I gave you that pops up all the time, if I gave you y equals to e to the x, just a summary, then it tells me that the derivative dy dx is e to the x, right? These are what I like to call base derivatives. Base derivatives. So if, yes, hello, hi. Question, no. So the other one, y equals to sine of x, I think everyone would say this is, it's cos of x. So someone's mic's not muted. Okay, thank you. So you remember this, right? Y equal to sine x, the derivative is cos x. Now, maybe you can help me here. And let's go through this quickly. So if I got y equals to cos x, what's the derivative, anyone? What's the derivative of cos x? Hello? Right, there's a minus sign there. Yes, correct. And then if you go for the fourth one, y equal to tan x, what's the derivative? It's a little bit more difficult. So that's x squared x. And you must be able to prove that. I'll show you that now. And then this one, y equals to cot x. Does anyone know the derivative of cot x? Anyone? It's minus cos x squared of x. So that's basically your general trig derivatives. I'm not using chain rule or anything that we used the last time we met. This is what you need to put up on the wall, so you should know that. There is no data sheet that's going to tell you this. That's something that you're going to take into the exam. Then we also had this very famous one, y equals to ln of x. What's the derivative of that? Anybody?
1 over x.
That's right. It's 1 over x, right? Thank you. And then we had something like, we must be able to prove this if y is equal to sine of x. This is important. Then y prime is cos x. And if you got y equals to cos x, be careful here now. There's no minus sign. Y prime is sine of x. We must be able to prove that. So these are the derivatives. It's like a data sheet in your mind that you should have this. And once we know this, then we can apply the rules. So for example, if I told you about the product rule, right, and we did tell you about the product rule, if I got a function y defined by the product of two, f of x times g of x, we all know that this big y prime, you differentiate the first guy, keep the second one constant, okay? And then you add, and then you keep the first guy constant, you differentiate the second one. It's easy as that, not difficult. So for example, I'll give you a function f of x is equal to e to the x times sine of x. And I want the derivative of this function, right? Which is f prime. Now look at the notation as well, which is df dx. We differentiate the first guy and keep the second one constant. Plus, you keep the first guy constant and you differentiate the second guy. And if you want to tidy up, this just becomes sine x plus cos x. There's your answer. Okay. So, right, someone's mic is on there. Let's have a look. Someone's mic. Okay, great. Thank you. So that's one. For practice, I would like the second derivative of this function. Right? Now, how would we do the second derivative of this function? Well, if I look at this, I can see that it's a product of two factors or two functions. The first one is e to the x, and the second one is sine x plus cos x. So what's the second derivative of this one? Right, it's f double prime, and the way we write this in notation, d squared f dx squared means second derivative of f with respect to x. So differentiate the first guy, keep the one in brackets constant, plus keep the first guy constant, right? And then differentiate what's in the brackets. Can anyone tell me what I write in brackets? What's in the brackets?
Where to?
Hello? Hi? Anyone? What would I write in the brackets?
Cos minus sin x.
Right. The first one, would it be minus? Okay, what's the derivative of sine x?
Cos.
Right, thank you. Right, and then what the derivative of cos x?
Negative.
And that's it, you see? But think about it. Can I simplify this? Let's look at some common factors. And you notice that if I do, e to the x sine x and e to the x minus sine x is going to cancel. Everyone agrees with that?
Yes.
So what's your final answer? 2 e to the x cos x. You see? So very simple. That's the second derivative. Now I can ask you to go even further and find the third derivative. If you got time, you can go do that. So we can
please
get...
repeat. I didn't understand.
Okay. Let's see. Which part? Are you happy with the first derivative?
Yes, I only understand the first derivative.
Right. Are you happy up to this point here?
Yes.
Right. So I'm saying that this function now, if I want to differentiate again the second derivative, it's made of two functions. There's the first one in blue, agreed, e to the x. And the second one I'll put in green, which is sine x plus cos x. So I'm treating the f prime as a product of two functions, the one in blue times the one in green. Are you happy with that?
Yes.
Right. So what it says is, what's the rule? The rule says keep the first function. You can differentiate the first function, keep the second one constant. So there's the one. Derivative of the blue function is e to the x. I kept the green function constant. Are you happy with that?
Yes.
And then I keep the first one constant and I differentiate the second one, which is the green one. The derivative of the green function, if I can call it that, ddx of sine x is cos x, ddx of cos x is minus sine x. Are you happy with that?
Yes.
Then you open up the brackets and you simplify, you end up with that.
Oh, thank
Easy
you.
peasy.
Thank you, sir. I understand.
All right. Excellent, excellent. So guys, just be careful. We could ask you for second derivatives or even third derivatives in the exams. I'm not sure why third, but let's try something else. What about something, I'm not using chain rule. I want to keep it simple for now. I'm going to go g of x, and that's equal to e to the x times ln of x. Right? So I want the derivative of this function. Right? So we got to treat one as constant. So g prime, firstly, I will differentiate e to the x. That's what the rule says. I'll keep ln of x constant. I'll just put it in brackets. Then it's plus, you keep e to the x constant. And what's the derivative of 1 over x? So I give you the answer. The derivative of ln x is 1 over x. Okay? And so you take e to the x out as a common factor, and we end up with ln x plus 1 over x. So straightforward, not difficult. So I'm just basically illustrating the product rule to everyone with simple functions, no chain rule as yet. Okay. Now, if you got the product rule, then we must have the quotient rule. And you must also learn the quotient rule in general. So if I've got a function y equals to f over g, where this function g of x is not 0, then its derivative is going to be f prime g minus g prime f all over g squared. That's the rule. Okay. So now in the exams, they're going to give you things to differentiate. So for example, I gave you a function f, which is ln of x over e to the x. Let's keep it simple. What's the derivative of this function? So of course, f prime, what does it say? You differentiate the first function, which is 1 over x. You keep the second function, which is the denominator, constant. Then there's a minus sign. Keep the first function constant. Differentiate the second one. All divided by the 1 in the denominator all squared. So this becomes, I take an e to the x as a common factor on top, and the bottom you got e to the power 2x. But guess what? So my final answer, if you wanted to make it look pretty, is that over there. Does that make sense, everybody? All right. So another way of doing this, another clever way of doing this, and this is where you get part marks in the exams. If you're not sure and you want to do this slowly, I think someone's mic's on there, guys. If you want to do this slowly, watch this, right? Let's take that function that I spoke about earlier, y equals to cot of x. And I want to find the derivative of cot of x. We know that we write cot of x as cos of x over sine of x. So what you then do in the exams, if I was a student, I will do the following. I will say that this looks like f over g, where f is equal, where f is equal to cos x, and you tell the exam that f prime is minus sine x. G is equal to sine x. The derivative of sine x is cos x. You see, straight away, the examiner knows that you can differentiate at least once for these functions. Now, this function y looks like f over g. And if I want y prime, this is a beautiful way of doing it, guys. Minus fg prime all over g squared. And then from there, you start bringing these things in. So g is sine x. F prime is minus sine x. Minus f is cos x. You can put them in brackets. G prime is cos x. All over g squared is sine squared x. Beautiful, isn't it? And if you do the math, you can see what's happening in the numerator. And this is what I like about this technique. You're going to end up with a minus sine squared x minus cos squared x. You can take a minus sign out. So you end up with minus sine squared x plus cos squared x all over sine squared x. Now, can anyone simplify that for me? What is minus sine squared x plus cos squared x all over sine squared x? Anybody? What's the numerator equal to? Yes?
Sine equals to x.
Yeah. So this is going to be minus 1 over sine squared x. And minus 1 over sine squared x is minus cos x squared x. There you have it, which is what I told you about 10 minutes ago. Right over there. You see? So, okay, so it all works out. So the quotient rule, of course, we're going to ask you about the quotient rule, but it's never going to be that easy. That's the point, right? So it's going to involve the chain rule. It's going to become clumsy and it's going to be miserable. So for example, I got a higher order derivatives, but what I want to do is maybe test it in a slightly different way. And so I basically have the following: x double dot, I'm writing out an equation. Okay, let's write it like this. Y double dash is equal to y dash. Sorry, y double dash. I'm thinking of what we call a differential equation. Don't worry about the words I'm using. So y double dash minus y equals to 0, right? This is what is known as a second order differential equation. Don't worry about the terms. I'm just giving you this. But what I'm saying is I want you to show that if y is equal to a sine x plus b cos x, that this thing, if I put it in here, will make the left-hand side 0. Of course, it might be a restriction on a and b. So what we're saying is that if you got this equation here, y double dash minus y equals to 0, then a solution to that equation is this thing over here. You'll learn this in maths too. This is called a simple oscillator, simple harmonic oscillator. So let's see how we work with this. So firstly, we got y. Now I need y dash, which is a cos x. And if I differentiate b, it'll become minus b sine x. That's y dash. But I need y double dash. I differentiate again. Right, everyone happy with how I got to y double dash? Hello? Right, everybody? Now I take this and I put it in there. Let's see what happens. Minus a sine x minus b cos x. And then you got minus y. What is y? Y is this guy over here. Right. So you'll notice here that I've got a minus a sine x and a minus a sine x. Sorry, this should have been plus. I made a mistake. That should be a plus sign over there. So the minus and the plus will cancel, and the minus and the plus will cancel, and you end up with 0 equals to 0.
Sir,
Yes, question.
didn't you say when we have two functions, we differentiate the first one and keep the second one constant?
Yes, but this one, remember, this one is a constant. A is a constant. So we can't, if you differentiate a constant, it's going to be 0. And also, this is not a product, it's a sum.
Oh, I understand.
Yes, so I know what you're asking. So if you got y equals to u times v, I agree. It's u prime v plus u v prime. But if y is equal to u plus v, what's happening there? Y prime is u prime plus v prime. Are you happy with that? They're two different things.
Yes, I understand.
Good, excellent. Any other questions, guys? I like this one here. I think there's a third question there. You're given an equation called a differential equation to give you the solution of the equation. And then what you have to do is then verify that it is a solution of the equations. All right. I'll give you an idea, and I think this is very interesting. Sometimes it's nice to see where this is going because students don't get to see it because very few people actually do research. I'll show you something quickly, and then you can really appreciate why we do this sort of calculus and what we can actually use the derivatives for. So I'm just going to look at an article that we're writing right now with a group of people on gravitational waves and dark energy, and I'll show you why this is so important. Here we go. Sometimes it's nice to see the applications. We don't get to see it in class. We don't see it in textbooks. So here, so there's a paper that we're writing. Don't worry about the title. It's got to do with these stars that we find in space, neutron stars. That's me over there, by the way, humbly sitting somewhere in between. I don't know who the other guys are. But here's the mathematics, guys. So what we're going to do is model this star, and the star is colliding with another star. And when they collide, they're going to give off some waves. And so there's a whole lot of equations coming in. This is one equation that we need to solve. And you can see those primes there. That's like dH dx, for example. And so it comes down to actually solving these equations. And once you solve these equations, you have a solution that describes a star. Then you've got to ask yourself, is this a physical solution? So next week we'll be doing integration. So we do plots and we do pictures like this, like that. And then from these pictures, we're able to tell whether when you point a telescope into this to the sky, whether which region should be looking for. So for examples, if you're looking for a star greater than 3, you'll notice it doesn't exist. So in this model, a star greater than 3 times the mass of the sun will not exist. So don't waste your time looking for it. That's what this calculus is giving us. Beautiful. All right. So I just thought I'll show you some applications of the work that we're trying. And it's really the first year calculus that I'm teaching you now that we're going to be applying. Pure differentiation. So if I look at another example of a higher order derivative, higher order basically means derivatives higher than 1, right? So for example, if I gave you one that you did in school, let's go back to school. F of x is equal to x cubed minus 2x squared plus 1. I want the fourth derivative of this function. Fourth, right? So what is f prime? Let's go with the first derivative. df dx is 3x squared minus 4x. The derivative of 1 is 0. F double prime is going to be 6x plus 4. F triple prime is going to be 6. And what's the fourth derivative, guys?
Minus 4.
No, what's the derivative of 6?
0.
0.
0.
You see? So as you go higher, you see this, in this case, the derivative goes to 0, right? Because it's a polynomial. But if you take a function like this, say g of x is equal to sine x, then the first derivative is cos x. The second derivative is minus sine x. The third derivative is minus cos x. You can see what's happening. It sort of oscillates. The derivative of that becomes sine x. So the fourth derivative is equal to the function itself. And you can continue doing this, and you can go into a cyclical, cyclical derivative. So you can differentiate 100 times. It's not going to be 0. So you have these oscillatory functions, which we periodic functions. The derivative of e to the x, if you want the 10,000 derivative, will still be e to the x. And then the polynomials eventually will tend to 0. Okay, so just to give you an idea of that. Now you've also seen higher derivatives in this case over here. Look, f equals to ma. Okay, someone's mic is on. Okay, hello, hi. So have you all seen this equation here before? F equal to ma. Everybody?
Yes.
Right. Whose law is this?
Useful.
It's Newton's second
Newton's
law.
law.
Right, that's Newton 2, right? We know this is Newton 2. But what they didn't tell you in school, you see the acceleration there. The acceleration is the derivative of the velocity. If you differentiate the velocity, you get the acceleration, right? And the acceleration is the second derivative of the displacement. So interestingly enough, you can treat this as a differential equation. So the force is equal to m, and you can write that as, say, x double dot, where the dot means derivative with respect to t. So this becomes an equation, a second order equation. So it involves calculus. Hello, hi. Someone's mic is on there. All right, so we have these higher order derivatives, and you can see that how the second derivative in this case is related to the acceleration of the object, and the first derivative is related to the velocity. So these things have physical meaning when we are doing experiments, for example, or we are basically investigating motion of an object. All right, so extremely important in physics. Now, here's the problem. This gives students the biggest problem. We worked through it the other day and we had lots of fun with it. So let's see whether you remember what we learned last Friday. And it's called the chain rule. Okay. And I showed you why it's called the chain rule, because of composite functions. You take in the derivative of a function, of a function, of a function, of a function. So it creates this chain. But I don't like doing it that way. We understand where it comes from. But what we want to do is make sure that we get it right. So for example, here's a very good example. So if I take the derivative, let's keep it simple at the beginning, e to the 2x, and I want the derivative of e to the 2x. What is the base derivative? If y is equal to e to the x, the base derivative, its derivative is e to the x. Okay, but now they're not asking us for e to the x, they're asking us for e to the 2x. So the 2 is going to make a change to the derivative. And so what we do is, my method is very straightforward and simple. We take the inner function, which is 2x. I call it the inside function, or innermost function is 2x. So what is the derivative of 2x, anyone?
2.
It's 2, right? So that's there. And what's the derivative of e to the something? What's the derivative of e to the something? It is?
Something.
It's e to the something. Don't say 2x, just say e to the something. And there's your answer, and walk away from it. It's straightforward, nothing difficult. Okay? So the 2, just to remind you, comes from d dx of the inner function, which is 2x. Now, when you're watching the video, you would understand. So similarly, if I have something like, let's say another example, y equals to sine of 3x. Now, the inner function is 3x. So what's the derivative of this function, anyone? What's the derivative of 3x? Someone's mic is 3x would be? Okay, someone's mic is on. Okay, thank you. Well, what's the derivative of 3x?
3.
3. And what's the derivative of sine of something?
Cos of something.
Oh, lovely. There we go. Is everyone with us here? Is everyone happy with that? Okay. So while we're there, I just reminded, can someone give me the second derivative of this function very quickly? Let's test you. What's the second derivative of this function?
I guess it's
Yeah.
sine 3x.
Right. Negative, right? Okay, but let's start again. Let's start again and do this slowly. So what's the derivative of 3x?
3.
Right. That
3.
3 is going to come to the front, right? So you're going to put a 3 and there's a 3 already there. Okay, ran out of electrons here. Let's have a look. So we got to have 2 3s. Yes? Is everyone happy why there are 2 3s there?
Yeah, I
Yes.
don't understand why we have 2, 3.
Okay, coming up now. I'm just charging my stylus. It ran out of electrons. Always, I don't understand why it runs out of electrons. All right, so why is it? So you're happy with this 3, yeah.
Yes.
Now, if I'm differentiating again, remember the inner function is 3x. So I've got to differentiate 3x again. What's the derivative of 3x?
It's 3.
Yeah, so there's that 3 over there. But remember, there was a 3 already in front, so it must keep that 3 there. Are you happy why there's 2 3s now?
No, I still don't get it.
Aibo. All right, let's go again. Y equals to sine of 3x. Let's start over here. Y equals to sine of 3x. What is y prime? You differentiate the inner function, what do you get? 3.
3.
Right. What's the derivative of sine of something?
Sine of cos of something.
Right, there we go. Now we're going to go one more time, right? This 3, bring it down. Let's focus on this function here. What's the derivative of cos of 3x? What's the derivative of 3x?
Is 3.
Aibo, there we go. And what's the derivative of cos of something?
Minus sine something.
Yeah, we can all go home now. Game over. That's the answer.
Oh,
You
I
have,
understand.
yes, do it slowly. So the final answer will be minus 9 sine of 3x. That's it. You see? So that 3, because it's there, you just got to carry it. You can't lose the 3. You can't drop the 3. That's the important thing. Right. Let's try another one. Chain rule. Chain rule is beautiful. I've got a function f of x. Now I'm going to say this is tan of 2e to the x. Oh my goodness, this is beautiful. What's the derivative of this one? Anybody? What's the derivative of this function?
2.
Starting on the ins. Yes, 2. Yes.
E to the x.
Brilliant. Then
X squared.
you don't need me as a teacher. That's it, 100%. Right? So let's look at this again. How did we get that? The derivative of 2e to the x is 2e to the x. The derivative of tan of something, okay, the derivative of tan of something is x squared of that something, and we got the answer. Are you happy with that, guys? Yes?
Yes.
Right, let's try one more and make sure that we understand it. I want the derivative of g of x equals to, let's make it interesting now. Why does it keep changing? Sine of cos of ln of x squared, just for fun, right? Give me g prime. If you got a piece of paper, write it down, and then we'll discuss the answer. I want sine of cos of ln x squared. Let's see. Now these things they don't ask in the exams. I don't know why they don't ask these exams, because these are pretty good questions. But anyway, let's go for it. Yes, what's the answer?
2x.
2x, right? Let's start. Lovely. You started off with the inner function. The derivative of x squared is 2x. Thank you. Oh, wow, what's happening here? It ran off electrons again. Sorry, 1 second. 1 second. So, yeah, so you're right. It's 2x.
1 over x squared.
I was waiting for that. That is the classic one. That is the classic one. So watch. I'm going to put each of the derivatives. So the x squared will give me the 2x. I agree with that. Then the derivative of ln x, I'll put this in color. The derivative of ln of something is 1 over that something. Yes. What's the next one?
Negative minus sine ln
Right.
x squared.
Of ln of x squared, which is the blue one, times the final one would be
cos,
Yes,
cos
cos of ln x squared.
x squared.
That's it. And then you guys can simplify that if you want, and that gives you the first derivative of this function. Are you happy with that?
yes.
Yeah. And you might think, but this is so odd. Look at this, cos of cos. Do these things actually exist in nature? And the answer is yes. They do exist in nature. So well done, guys. Please watch the video. Generally, they don't ask you questions. This is my special question. But if you can do something like this, then everything else they ask you in the exam is going to be pretty straightforward. Why do the easy stuff in class and then go in the exam and find the hard stuff? You rather do the difficult stuff in class and it becomes easy in the exams. That's my take on this thing. Okay, so that gives you the basic stuff up to the chain rule. So we know quotient rule, product rule, power rule, and now we know the chain rule, which is for me the most powerful rule in mathematics. But there are other forms of differentiation as well. Now the next form, I know you love me up to this point. Everybody loves me teaching, but the next one you're going to dislike me because not many people get this. But I'm going to try my very best to teach you so that you understand it. And it's not difficult, so don't overthink it. This is where many of us will part ways. It's called implicit differentiation. And I've struggled to get this across to some students over many years because they overthink. So the idea here is, so far we've been differentiating and it's explicit. So what is d dx of e to the x? You can see the function depends on x. You can see it, right? But this one is implicit, which means the function is a function of x, but not explicitly. So you end up with a function like this. All right, now this looks confusing. And what I don't like about whatever's put here is they should have also mentioned that if you want the derivative of a function f of y, but y is a function of x, then the derivative is given by f prime of y dy dx. It's actually the chain rule. Okay. Now it looks a bit, this is why I don't like starting off with very technical things. So let me ask the question, and this is my method of doing it. Guys, there's going to be one question in the major test too. It should carry about 5 to 7 marks in the exams. So pay careful attention now. If I had to ask you, what is d dx of x squared? What's your answer? It's not a trick question. What? Yes,
2x,
it's 2x. Yes,
2x.
perfect. That's right. But now, what is d dx? Watch this now. Of y squared, where y is a function of x. What's the derivative of y squared, where y is a function of x? Most people will say 2y, and that is not true. No, it can't be. There's no x there. You see? There's no x explicitly. That's what we're saying. Sorry, yeah, you were right if you said 2x here. But for this one,
X
okay.
exponent 4.
All right, you say 4. Okay, that's good. That's good. But let me ask the question. Let's go back in time. What is the inner function here of y squared? What is the inner function? The inner function is y. Everyone agrees with that. And then you square it, right? So the inner function of y squared is y. What is the derivative of y with respect to x? We're using the chain rule. Watch this. Of y squared. So what we have to do is we have to differentiate the inner function. The inner function is y. So if I differentiate it, I will get dy dx. Now, what is the derivative of something squared? Anybody? What is the derivative of something squared?
2 to the something.
That's right. It's just 2y, isn't it? So the derivative of y squared is 2y, and dy dx we write as y prime. That's it. That's it. So the derivative of x squared, which is explicit, is 2x. But the derivative of y squared is not just 2y, but y prime. The y prime comes from the inner function. It's the chain rule. So if you are differentiating implicitly, you're always going to get a y prime coming up. So I'll give you another question. What is not d dy, but what is d dx of y cubed? Let's see what you say.
3y cubed y
That's
prime.
right.
Right.
100%. 3y squared, normal. And of course, there should be a y prime. The y prime comes from the y, because you write it like this. D dx of y all cubed. I ran out of electrons again. This pen is just dying. It's y cubed. And then you differentiate the inside, and then you differentiate y cubed. So I'll show you just now.
So just leave it like that. You don't substitute with the x
No, you
values.
don't.
Like,
Yes, correct. Because we don't know what those x values are. That's the problem.
but see, there's x squared was differentiated to be 2x. You don't take
Correct.
the 2x and substitute.
Yeah. And the reason for that is because the x appears explicitly. See, there you differentiate with respect to x, and the function is given in terms of x. Here we differentiate with respect to x, but the function is given with respect to y. You see, that's the issue. You see that there's two very different things. Okay, let's have a look. Like for example, look at this one. I said differentiate this. I want you to find dy dx. Now you look at this thing and say, how do I work this out? Remember, remember y is a function of x. But we don't know what that is. Y could be e to the x. Y could be sine x. But we're not telling you. We're just saying it's a function of x. Right? Watch how we differentiate. This is how the question is asked in the exams. If I differentiate x squared, what is x squared? What is d dx of x squared?
2x.
2x.
It's 2x, right? Now, what is d dx of y squared?
2y.
0.
2y? No, with respect to x, but y is a function of x. Y is a function of x. So it'll be 2y, and wherever there's a y squared, you put a y prime.
Y
Must have
prime.
a y prime, correct. What is d dx of 2x?
2.
Right.
2.
What is d dx of y?
Y prime.
Y prime.
Would it be y prime, or just y prime?
Y prime.
It'll just be y prime. It'll be y prime, correct. Is everyone happy y is just y prime? Because it's d dx of y squared is 2y prime, but there's no square here. It's just y prime. So how do I find y prime? You bring the y prime on this side, you'll get 2y prime minus y prime, and take the 2x on the other side. Y prime is a common factor, equals to 2 minus 2x. And there we have the derivative of this strange looking thing here. 2 minus 2x over 2y minus 1. That's how I find the derivative. You differentiate implicitly everything, and then you solve for y prime to get dy dx. That's what this implicit differentiation is. So y is not a function of x. So to give you an idea explicitly, I'll give you another example. Let's see whether you understand what I'm saying here. What if I told you that I got a function, it's a function of x, but it's given as e to the y, where y is a function of x. What is df dy? Sorry, df dx. Y is a function of x. So what is the inner? That's right. Would it be y prime or e to the y prime?
E to the y.
That's right. That is right. So if I do this, my innermost function, remember, is this here. My innermost function is y. If I differentiate y, I'll get y prime. Then the derivative of e to the something is always e to the something. There's your derivative. Y prime e to the y. You see? So it works out quite nicely, but it requires some sort of practice. I know that students don't like this y prime. Why is it there? It comes from the chain rule. You got to differentiate the innermost function. That is important. All right. Questions? Think about this one here in the meantime, guys. All right, guys, if you got a piece of paper and you're writing, I'm sure this becomes quite interesting because you got this. Now we have a slight issue here. When I say an issue, the problem is how do we deal with this part here? Watch this. You have to be very, very careful over here. It's a product. So the question is, how do we deal with the product 2x y cubed, right? Especially if y is a function of x. So let's take a quick look at this and see whether we can come up with something that's interesting. All right, here we go. So go ahead and I'll talk about this a little later. And I want to extend this question and make it more interesting than what they have here. All right. So let's take a look and start differentiating implicitly. Let's put it this way.
8x.
Okay, the first question here would be 8x if you differentiate, correct? Now this is a product, yes?
Plus 2y squared prime y prime.
Okay, and what about the x?
I think the x we won't use it.
We have to. So what we have to do is treat this as a product, xy cubed. The derivative of x, I'll put there as 1. Keep y cubed constant. It's plus the derivative, keep x constant. And as you said, the derivative of y cubed is 3y squared y prime. You see how that blows up? So just a very simple product becomes that over there. I'll discuss that just now. Now, what's the derivative of minus, I'll put the minus 5, but what's the derivative of y squared, anyone? What's the derivative of y squared?
3y y prime.
2y, yeah? 2y, yes. Okay, great. So that's what you have. Yeah, 2y y prime. So if we open up the brackets, what would we get? We'll get 8x plus 2y cubed plus 6, watch this, x y squared y prime minus 10 y prime equals to 0. Now look at this, what they're saying. Find dy dx, which is the y prime that we have. So these two terms have y prime here and there. So you'll take out the y prime as a common factor, and the ones that don't have y prime, put them on the other side. So I got y prime into 6xy squared from here minus 10y from there. And these two fellows go to the other side, becomes minus 8x minus 2y cubed. And if I divide both sides, I'll get minus 8x minus 2y cubed all over like that. There's your y prime. Okay, now they are asking for the derivative when x is 1 and y is 2. So you put x equal to 1 there, y equal to 2 there. You substitute values here. And that will give you a number. Let me show you what that is. So at x equal to 1 and y equals to 2, that's 1 times that gives you that minus 2y into 2 cubed. You just do a direct substitution. Then 6xy squared is 6 into 1 times 2 squared minus 10 times y. Times 2. I'll let you evaluate that. That's just going to become a number. I don't like this question. It's too easy. Because once you got the derivative, I would like something better than that. Find the equation of the tangent. Find the equation of the tangent to this plane. You see, this thing here is not a curve. It's a plane. It's a two-dimensional surface. So I'd say find the equation of the tangent to the surface at x equal to 1 and y equals to 2. And then you think about metric and you say, hey, hang on. The derivative at a point is the gradient of the tangent. So at this point here, this becomes the gradient of the tangent. The tangent is a straight line, y equals to mx plus c. I've got m, I can find c because I have this. Okay. All right, that's great. That's a great discussion they're having there on tangent planes. Very good. Excellent. Now, let's not worry about too much there. Let's choose. Okay, can someone choose a question for me to do here? Look at these questions and let's see. Okay, can I? Which one? Number 3.
5.
5. Okay, let's try 3 first because of the cos y. I want to see how you handle cos y. Right? These are the solutions, by the way. So when you're watching the video, make sure you do these questions. If you do these questions, you're well prepared for the exam. But let's try question number 3. Sine x plus cos y equals to 1. Right? Very quickly, let's see. Sine x plus cos y equals to 1. And let's see what we come up with. This is question number 3. Sine x plus cos y equals to 1. We want to find y prime. So the question would be find y prime. Okay. So if I differentiate sine x, we all know. Okay, if I differentiate sine x, I will get cos x, correct?
Minus sin x
Right.
y prime.
That's it. Thank you. So the derivative of cos y, now watch. The inner function is y. The derivative of y is y prime. The derivative of cos of something is minus sine of that something, and the derivative of 1 is 0. Are you happy with that?
Yay.
Right. So what's the final answer?
Y
You take
prime.
is equal to
Cos
minus
x minus
all
cos
over
minus sin x.
over minus sine y. That's your answer. Right? The minus signs will cancel, so you get cos x over sine y. Now, please don't tell me that cos x over sine y is cot of x over y. Oh my goodness. It's leave your answer. This is the final answer. Because one year someone wrote this. And I gave him the marks for this calculation was 3 marks. He scored what is that?
0.
Exactly. That's what he scored, a 0. How can you write that? My soul left my body that way, that day when I saw that. Oh, students can be amazing at times. So be careful. This is very, very important that you don't do silly things in the exams and you don't violate the laws of mathematics. So this implicit differentiation is easy, but someone also mentioned, let's try question 5. I think that's a nice question because they're even giving you, and we know the answer is 2. So with this time, let's see we actually get the constant 2. Okay, so x squared plus y squared minus 2x minus 6y plus 5 equals to 0. I don't know whether I can remember this, but I'll create a new slide. And let's see whether we can come up with something here. Right, new slide. Let's see. Keep. Right, so we got implicit differentiation covered, which is very nice. It's a nice section, but you know it requires a bit of work. So this was question number 5. And it goes like x squared plus y squared minus 2x. Guys, this looks very familiar. It's something that you've seen in school. I don't know. Do you recognize x squared plus y squared minus 2x minus 6y plus 5 equals to 0? Can anyone describe this curve to me? What if I had to sketch this thing, what would it be?
Exactly.
It's a circle. It's a circle. Absolutely right. This is a circle. If you remember in analytical geometry in grade 12, when you complete the square.
So please be vigilant. If the situation is out of pockets, keep safe being there.
Oh, this mic on, I think. Yeah. Okay, great. Guys, have a look at this here. Do you remember that this is a circle, analytical geometry? Complete the square.
Yes.
Yeah, this will be so that'll be a nice exercise for you, but we're not worried about that. What we're worried about here is, can we differentiate this function? But this is a circle. So let's start differentiating. Let's see what we come up with. Perfect. Thank you. So we're going to go, what's the derivative of x squared? Hey.
2x.
Right. So this is 2x. What's the derivative of y squared? Let's see whether you get this one right.
2y prime.
Yes, it's 2y, y prime. The moment you differentiate y with respect to x, you have to have a y prime. What's the derivative of minus 2x?
Minus 2.
Right. And what's the derivative of minus 6y?
Minus 6y prime.
Yes. And what's the derivative of 5?
0.
That's it. So you group the y primes and take that to the other side. So you have 2y, y prime minus 6y prime, tick it and put the others on the other side. So 2x goes on the other side, becomes minus 2x. The minus 2 goes and it becomes becomes plus 2. Take y prime as a common factor on this side, and you're going to get 2 minus 2x. You can reverse that. So what is y prime equal to? 2 minus 2x all over 2y minus x. But they gave us something called an initial condition. That's what it's called. This is called an initial point or initial condition. It's 3, 2. So at 3, 2, y prime is going to be 2 minus 2 into 3 all over 2 into 2 minus 6. That is 2 minus 6, which is minus 4. 4 minus 6, which is minus 2. And for sure as God made little red apples, the answer is 2. There we have it. And there's your 4 marks or 5 marks, whatever you want to call it. Simple, isn't it? Now, sorry, please do ask questions. Anybody?
Can you do number 6?
Number 6. There was number 6 there. Oh, yeah, yeah.
The last one.
Oh, this is beautiful. But not that good. I would have preferred a y being there, but let's try that. Sine squared x plus 3 cos y. Yeah, that one's too easy. But anyway, let's try it. Sometimes it's worth doing these things. You'll never know. They pop up in the exams. Yeah. No, this is not a bad question at all, because we don't do things like sine squared. And when you don't do them, guess what? They do come out in the exams. It's such a weird thing in life. All right, here we go. Number 6, yeah? There we go. What is this? So we got a function, sine squared x plus 3 cos y, and that is equal to a half. And the point they gave us is pi over 4 and pi over 2. Okay. Pi over 4 and pi over 2. Okay. So let's take a look and see whether we can actually get this. Now, the other point I was going to make is this. You see, sometimes in the examiners can be really bad. I'm not one of those, but they can be bad, and they will tell you this. Watch. Instead of giving you the x and y values, they will tell you at x equals to pi by 4. So now question then is, how would I find y? Anyone? If they only gave me the x value.
Substitute to the original equation.
Absolutely, 100%. You'll substitute in there. You'll get, watch this, you'll get sine squared of pi over 4. Here goes my pi over 4 plus 3 cos y equals to a half. But sine squared of pi over 4 is 1 over root 2 all squared. Why is this thing not writing? A half. That's a half, and that half will cancel. So you're going to get cos y equals to 0. Notice y is pi by 2. So just be careful here. They will give you the x value. You have to work out the y value. You have to substitute in the original equation and solve. Okay, so that's the first part. Now let's start differentiating this thing. Let's see whether we get this right. What's the derivative of sine squared of x? You see, I'll give you a hint. Sine squared of x, yeah, is sine x all squared. So if I had to differentiate, the inner function is sine x. What's the derivative of sine x?
Cos x.
Right, it's cos x. Okay. Now, what's the derivative of something squared? Like what's the derivative of something squared? It's 2 times that
It's
something.
2 times something.
Yes. So the derivative of sine squared x is actually this here. Is everyone happy with that?
Yes, yes, yes.
Right. Good. Now 3. Now here, watch this. This is cos of y. The inner function is y. What's the derivative of y with respect to x? It's y.
Y prime.
That's it. And what's the derivative of cos of something?
Negative sign
of something, man.
Oh, lovely. I love the way they said that. And that is 0. With such passion. It is negative sign of something, right? So now let's work this out. We want to solve for y prime. So we're going to get minus 3y prime sine y. Take this on the other side, becomes minus 2 cos x sine x. So y prime is what they want. All over minus 3 sine y. So the minus and minus will cancel. Sorry. And you're going to get 2 cos x sine x all over 3 sine y. And then you substitute pi by 4 and y equal to pi by 2. Hey, this answer should be 0, eh? No, it can't be. It can't be 1 over 3. That's not right. It can't be 1 over 3 because cos of pi. Oh, it's x. It's x. Sorry, it's x. Let's see whether that is correct. 2 cos of pi by 4 sine of pi by 4 all over 3 sine of pi by 2. Cos of pi by 4 is 1 over root 2. Sine of pi by 4 is 1 over root 2. 1 over root 2 times 1 over root 2 is a half. A half times 2 is a 1. And 3 times sine of pi by 2. Sine of pi by 2 is 1. Yes, the answer is 1 over 3. So let's go back and verify. Here we go, 1 over 3. Are you happy with that, guys? Question number 6.
Yes.
Yes.
All right, good. All right, so this is straightforward. It's not difficult. It's pretty easy. Do you want to take a quick break and I will just teach you one more little subsection? Is that okay? I just want to introduce this. Not going to spend too much time on it. Would that be okay?
Yes.
Should I continue and finish early, or should I take a break and then finish later? It's up to you.
Continue. Yes,
So,
yes, sir.
Yes.
okay.
Continue.
All right.
Yes,
Let's continue. Yes, it's fun. It's exciting, isn't it? It's like being in a nightclub. It's like being on the dance floor, listening to the DJ, popping and moving on the dance floor. Brilliant. So let's do this. I love mathematics. I love mathematics. So let's look at this thing called logarithmic differentiation. This bloody thing carries a lot of marks in the exams. It's unnecessarily difficult. Okay, but I want to teach you some simple methods, but it involves the chain rule. But guys, I want to take a step back here. And okay, before we do that, what is this logarithmic differentiation and why do we need it? So for example, let's go back to school, and this is way back to grade 10. These are the log laws, but as applied to natural logs, right? We know this. Ln of a product is the sum of these, ln A plus ln B. So these are pretty straightforward. They're not difficult. This is the power law, drops in front. Ln of E is 1 and ln of 1 is 0. These are basic laws that I introduced you 2 months ago, I think. But now, how do we use this to simplify and differentiate some very complicated things that involve quotients and products? So for example, let's say I wanted you to find the derivative. Watch this, guys. I want you to find the derivative of, say, this function over here. Now, that looks a bit difficult, isn't it? Because you got to differentiate the inner function, which is 2x squared over tan x. You have to use the quotient rule. And then you have to say ddx of ln of something is 1 over that something over there. So it's a bit messy. But there's another way of doing it. And that is, you would say, but hang on, this is ln of a quotient. I just want to show you question 2 because explicitly in terms of x. So ln of 2x squared over tan x. What is that? This thing goes like ln. Tell me whether you agree with this one. Is everyone happy with that first part there?
Yes.
So
Right?
isn't
Plus,
it for
Aibo.
for the
Yes,
second
yes,
law?
yeah, it's actually a minus sign there. I was just checking whether you're awake. Sorry, thank you. That's right, it's a minus sign. It's the second one. Ln of a over b is ln a minus ln b. Now, here's the beauty of this thing over here. If I now had to ask you to differentiate this function, right? What is the derivative of this thing? So if this was just y, what is y prime equal to? Well, I'll differentiate the inner function. What is ddx of 2x squared?
4x.
It's 4x, right? What is ddx of ln of something?
It's 1 over.
It's 1 over
One
that
over
something,
over
which is 2x squared. Are you happy with that?
Yes.
Right. Now, help me here. What is ddx?
Yes.
Very nice. I like that. What is ddx of tan x?
It's 1 over 10x.
It's
Sex
sec squared of
X.
x. Correct. And what is ddx of ln of something?
Tan
1
1
over
over
1 over
tan.
10x.
1
1
over
over
X.
10x.
Tan x, right? Yeah. That's it. So 4 over 2. So this now I can simplify that. That becomes 4 over x minus. I think this one can factorize as well nicely, and you should get something quite easy. I'm thinking that this is 4 over x, but remember tan x is sine x over cos x, and sec squared x is 1 over cos squared x. So if I just simplify this, sec squared x is 1 over cos squared x. And what is 1 over tan x?
Sir, it's 2 over x.
Yeah, this is 2. Thank you. That's true. Thank you. So 1 over tan becomes cos x over sine x. The cos cancels. If you want, this just becomes cos x times sine x. I'm just showing you that this guy can be simplified. Okay, so the reason for introducing logs, it simplifies these things. So now the question is, what type of questions can I ask you in the exams when it comes to logarithmic differentiation? And it goes like this. Now, if I had to ask you to differentiate this function, you can do this using the quotient rule. But then you see what's happening at the top. There's a product there as well. So it can be done, but it's messy, right? So when you see things like that, where you got products and then you got a quotient and it's coupled, it tells you what you do is you take logs on both sides. That's why it's called logarithmic differentiation. So if I take logs on both sides, I get ln y equals to ln of x e to the 3x over cos x. Now, if you look here, this is like ln of a over b, so that becomes ln of x e to the 3x minus ln of cos x. Is everyone happy with that? Sort of. Okay. Yes. What about this here, the product? How can I expand that? Isn't that ln of x plus ln of e to the 3x minus ln of cos x? So is everyone happy how I got there? Yeah. Now here comes the really important part, right? I want y prime. So what I have to do is I got to differentiate both sides with respect to x. What is the derivative of ln y with respect to x? This should be a good one.
Prime over y.
Excellent, 100%. You differentiate the inner function, you get y prime, and the
mati
derivative
budi.
of ln is 1 over y. So is everyone happy that derivative of ln y is y prime over y? Yes? Okay. Now, if I differentiate the left-hand side, what's the derivative of ln x? We should all know this one. What's the
1
derivative
over
of
x.
It's 1 over x. Thank you. Now, be careful here. What's the derivative of ln of e to the 3x? Let's start with the inner function. What's the derivative of 3x?
3.
Right. What's the derivative of e to the something?
Something.
E to the something. Correct. And what's the derivative of ln of something?
1 over something.
Yeah,
1 over something.
That's right. And there's a minus sign there. What's the derivative of cos x?
Minus
Sign.
Lovely.
Negative sin x.
Yeah. And what's the derivative of ln of something?
It's 1 over.
That's it. So that cancels, that cancels. We get 1 over x. Watch this. Plus 3. Minus and minus is plus. Sin x over cos x is tan x. But just be careful here. Watch this, guys. Here we got y prime over y equals to 1 over x plus 3 plus tan x. So we take the y and we multiply across. Watch. And you put a bracket there. There's your answer. So y prime is equal to y times that. But then you ask yourself, but what is y? There's it over here. So this becomes y prime equals to x e to the 3x all over cos x into. And there's your final answer in terms of x. So you take logs on both sides. At the end, you're going to end up with your answer being in terms of y. And then you ask yourself, what is y? Oh, there's the original question. You substitute, and there you get your 4 marks in the exams. But you look at this
Sir,
question.
please repeat the last step.
Oh, yes. Okay. So are you happy with this part here? Are you happy with how I multiplied the y across to give you this here?
Yes.
And then we said, well, what is y? Oh, there's y over here. So I replace y with x e to the 3x over cos x. Because you want y prime to be in terms of x, not y.
Oh, I understand. Thank you.
Lovely. Brilliant. So if you have a piece of paper, this is it. If you have a piece of paper in front of you, I'll give you 2 minutes. Work this question. This will carry 4 marks in the exams if it has to. This is a beautiful question, by the way. Differentiate this for me. Find y prime. Find y prime. Let's see whether you come up with something. Sure you would. Right, so tell me when you do have an answer, then I'll put up my solution, then we can compare answers, right? So I'll give you a minute and then let's see whether you can try and get that going. So while you continue differentiating, I'll do the first step. All right, so I'll take logs on both sides. So you must write this. You must write it like this. Don't just immediately expand. Like that. And then you start to expand. I think everyone should have had at least that step over there. Then this is a product. ln of 3 to the power 2x. Did everyone have that at least? Somebody? Anybody?
Yes.
Yes.
All right.
Yes,
Okay, so what we have then, if I write it here, you'll have ln y equals to, now this 2x can come to the front. So you're going to have 2x ln 3. But this guy can be written, I'll take an extra line here, is 4x minus 5 raised to the power half. Is that correct?
Yes.
Right, excellent.
Yes, sir.
So, right, so that becomes 2x. You can take as many lines as you want. The half would pop up in front. Minus ln of x squared. Okay, so everyone should have got to this point here at least.
Yes.
Excellent. Now we start to differentiate. And when we start to differentiate, the derivative of ln y we know is y prime over y. We expect that. The derivative of 2x ln 3, what is that? What's the derivative of 2x ln 3? You differentiate the x, it's 1. So isn't it 2 ln 3?
Yes.
Right, that's good, right? Because ln 3 is a constant, so don't do anything fancy. They just differentiate the x, put the constant. Now, let's go here. Watch here, you got to be very careful. What's the derivative of 4x plus 5?
4.
That's it. And what's the derivative of ln of something? That's
1 over
right.
something.
That's it. Now, be careful here. What's the derivative of x squared?
2x.
Right. And what's the derivative of ln of something?
1 over something.
That's it. There we go. We got the answer and we can all go home because this now becomes y. Hey, this, what happened there? Y prime is now equal to y into 2 ln 3. Half of 4 becomes 2 over 4x plus 5 minus 2 over x. Yes.
It is
Question?
ln for x minus 5, not ln for x plus 5.
4x. Oh, yes, correct. I don't know how I got a plus there. Thank you, thank you, thank you. There's a minus there, and I don't know how I put a plus there. Thank you. Minus, minus, and there's a minus there. Yes. Yeah. And that's it. There's your answer, guys. And then what is y? What is y? Someone's mic. Are you happy with that? And that's your final answer. It's easy as that, not difficult at all. Okay, so we learned a new method. We learned 2 new methods today: implicit differentiation, and we also got logarithmic differentiation. So there are 2 things that are extremely important when it comes to working out derivatives. All right, and I'll give you some homework. There's some homework for you. You can practice these examples. The solutions are here. The solutions are in brackets. And so try to do that. So the next time we meet, I will go over these questions here before starting the last bit that we do on differentiation, that's called parametric differentiation. But before I close, I want to ask a question. And I think it's a very important one. Watch this. So please, when you're watching the video, pause it here and make sure you do this and get the answers. Right? So we discussed that on Friday. But before we go, here's the important one. So duplicate. Now we know that the derivative of e to the x, if I got y is equal to e to the x, we know the derivative is e to the x. We know that. But what if y is equal to a to the power x? For example, y equals to 2 to the power x. What's the derivative of 2 to the power x? What do you think it is? Anybody?
2 to the power of x ln 2.
Right, that's perfect, right? But most people would think it's 2 to the power x, right? Now the question then is, thank you, that's perfectly correct. So where did the ln 2 come from? That's a good question, isn't it? because there's no ln here. Okay, yes, there's a ln there, it's ln of e, but we know ln of e is 1. So watch this, guys. And now if you think about it, that's the reason why the logarithmic plays a very important role. So if we go y equals to 2 to the power x, and if I take logs on both sides, then this thing becomes x ln 2, and you got ln y. If I differentiate both sides, I get y prime over y. And what's the derivative of x ln 2? Anybody? What's the derivative of
X
x
over
ln? If yeah, x ln 2. If you differentiate x, what do you get? You get 1,
One.
correct? So what's the derivative of x ln 2?
Then so
It's
Ln
ln.
2.
That's correct. So what is y? So what is y prime equal to? It's y ln 2. But hang on, what is y? 2 to the power x. So we're saying the following: if y is equal to 2 to the power x, then the derivative of that is 2 to the power x, as you mentioned, times ln of 2. In general, this is what we can say. If I got y equals to a to the power x, watch this, is very important. If y is equal to a to the power x, then the derivative y prime, I don't know what's happening over here, is going to be a to the power x times ln of a.
Ln A.
Yes, where a has to be a positive number. You have to be very important here that a is positive, because I can't take the derivative of a negative number there. So that's something new, and it's something that we need to know for the exam. So if I had to ask you as my parting shot, and I shall put on the video so you can actually see my smiling face, because this was a brilliant lesson. I really love these things. I love calculus. This is my favorite thing in the world to do. Like most people would have a burger for lunch or biscuits and coffee. I love doing calculus. So I'll switch on the camera and I'll be smiling. Okay, so can someone give me what is the derivative of 3 to the x?
3x then 3.
All right, 3 to the power x times ln 3. So what is the derivative of, now pay careful attention to this one. This is my last one. 3 to the minus x.
3 to the
One,
minus x will
1/3.
1 over 3, okay? So what is the inner function? So you got 3 to the minus x. So if I take ln on both sides, I get y prime over y is equal to minus x ln 3. Let's imagine that. Y prime over y, if I differentiate, or if I take ln on both sides, I get ln y is equal to ln of 3 to the minus x. The minus x pops up in front. You get minus x ln 3. If I differentiate that, ddx of minus x ln 3 is minus ln 3. Then you got y prime over y is equal to minus ln 3. So my final answer, y prime, if you just imagine that, is minus ln 3 times 3 to the minus x, which can be written as minus ln 3 over 3 to the power x. Can you imagine that? Or can I write this down? Should I?
Yes.
Right, so watch this, use your imagination. Let's see. I'll take away that camera because it's quite a scare, that video. I myself get scared looking at myself there. But let's have a look at that. Where is this coming from? No, I haven't stopped sharing yet. So what happened to my screen? Don't know what happened to my screen. Aibo. Guys, can you see my screen at the moment?
yes.
Yes.
It says you are sharing screen, but I don't know what's happening. I want to get back to, oh, there we go. Right, let's go here. I want you to appreciate this here. So if I gave you y equals to 3 to the minus x, you take logs on both sides. The minus x is going to pop to the front, so you're going to get minus x ln 3. And if I differentiate, I'll get y prime over y. And the derivative of minus x ln 3 is minus ln 3. Which then tells me if I multiply by y, I'll get y prime equals to minus y ln 3. That's the only difference because I got a minus sign there. But what is y? Y is 3 to the minus x. So y prime is equal to minus 3 to the minus x ln 3. I don't like negative numbers. So that becomes minus ln 3 all over 3 to the power x. Can we see that, guys? Should I write it on a new slide so it looks better?
Yes.
Yeah, let's do that because I realize now I can simplify that even further. This is beautiful. Watch. So let's go here. Let's keep it general. Why not? Why don't we do this? Y equals to a to the minus x. How do we differentiate this? We take ln on both sides. And this becomes minus x ln a equals to ln y. Now, if I differentiate, I'll get y prime over y equals to minus ln a because d dx of x is 1. So what is y prime equal to? Minus y ln a. But hang on, what is y? There's y here. So that becomes minus a to the minus x ln of a. So y prime, I don't like the minus x there, so that becomes minus ln of a. A to the minus x is 1 over a to the power x. But we can do something even better than that, guys. Can you spot this? Who agrees with that? That minus sign jumps to the top, so becomes a to the minus 1, correct?
Yes.
Somebody, any? Yep. And then finally,
Yes.
and finally, we can even do this even better than this. Watch. Who agrees with that? So there's no minus signs. How cool is that?
Yes.
See?
Cool.
That's it. Yeah, it's cool. And the thing is, we should have spotted this right at the beginning because a to the minus x, guys, we know is 1 over a to the power x. So we didn't have to go through all of that trouble to spot it. The derivative of 1 over a raised to the power x is going to be y prime is going to be ln of 1 over a and then 1 over a to the power x. We didn't have to go through this whole derivation to see that. But that's how you do it.
Are we done?
Yes, we are done. Thank you. Yes. Are there any questions, comments, guys? Because we'll stop the lesson now because the video gets too big, then I can't upload this video. If I can't, then I'll put it onto a Google Classroom. I'll share the link with you. But if I can, then I'll put it onto Moodle. Okay.
So I have a question.
Yes, please do ask.
So what we're doing here is we're finding the formula of the slope or the slope, right?
Yes, absolutely. At a particular
So
point.
at a particular point, so whether it's a circle or a graph.
Yeah,
and so
that's
you
right.
can ask us to find the equation of the tangent of that particular point.
Correct. So when you find y prime at that point, that becomes the gradient of the tangent.
Okay, I just wanted to clarify that.
Yeah, but remind me on Friday, I want to emphasize that point. I'll come up with a simple example where we get to see how the tangent and the gradient, how you could work out the equation of the tangent to the curve if you're given the function and the point. So if you remind me on Friday, I will show you how to do that with a nice illustration. So
Okay,
it's nice to know these things as well. Even if you're not being tested or examined, it's nice to know these things. It's very important. You guys are becoming engineers. So who knows in the future they would ask you to do things like this. All right. So guys, thank you so much for being so patient going through this. We've now covered quite a bit of work. On Friday, we finish off with differentiation. Next week, Tuesday, we start with antiderivatives. And guess what? By next Friday, this course is over. All right. And what I like to do when I say the course is over, it doesn't mean we stop coming to class, because I want to use that Tuesday before the test. I want to use that as a revision lecture to cover all the work that we covered. So the Tuesday before that Friday, the 23rd, we write, I want everyone to be ready for this test. And you should be quite relaxed and aim for an A. It's as simple as that. All right. So guys, thank you. Yes, you have any questions? Any more questions, guys?
Yes.
Sir,
Yep.
Ladies
I can,
first.
sir,
Okay.
I cannot access the video for the Friday before the 29th of April.
Why is it too large? Did I upload it? No, I didn't think I uploaded. Did I? No.
No,
I sent
I
a
can't
link.
see it.
Oh, okay. I'll have a look because I sent a link. So it's uploaded onto my Google Classroom. I couldn't
Oh.
upload it onto Moodle. So I'll share the link with you guys that you can access it there. Yeah.
Oh, thank you.
Yes, and any other ones? Or I could put it up on YouTube if you want. Yes.
So where can I download the past papers so I can practice?
Right. All the past papers, including tests and any of the major 1, major 2 is actually on Moodle. So if you go onto Moodle and you scroll down, you'll see Dr. Ali has uploaded anything that's relevant for us. So you'll see maybe 2022 test or 2023 tests. He was kind enough to upload these tests to us. Yeah. So everything is in electronic format, PDF version.
Okay, thank you, sir.
Yeah, and then all the questions that I discuss over here are actually based on past test questions. I don't make them up. Maybe now and then I do, but most of them are from the past test. So that means we're actually revising for the test at the same time. All right. Any other questions, guys? Are you all happy so far? Good. Right, so I'll see you guys on Friday, and hopefully after a long time we'll be in Mansfield Hall, face to face, and that will be a really cool lecture as well. So thank you so much, and watch out for this video. Make sure you go over it and prepare, and then on Friday we finish off with differentiation. So thank you. Don't forget the LEQs or MEQs and MEQs. If you have a link, please fill that. Give your opinion, state your opinion, or if you want any changes to the course. But with those LEQs and MEQs, we don't have practicals. So I don't know why they ask about practicals in mathematics. I asked them to take that out, but they still leave it there. So yeah. So thank you so much, and I'll see you on Friday. Stay safe, guys, and yeah, take care of yourselves. Bye for now.